Okay, in this video I'm going to work out the radicals in complex numbers review A so that you have a video of it. What we need to do is get the eraser to work. Okay, so what we need to do is break this up into any sort of perfect squares. 54 is 9 times 6. So what we can do is we can rewrite this as the square root of 9 times the square root of 6. And any perfect squares will come out, so the 9 will come out as a 3. So this is 3 times the square root of 6. For the next one, what I have is I cannot have any square roots in the denominator. Now we have two choices. We could take this times the square root of 63 over the square root of 63, and that would leave me with 63 in the denominator and some large number in the numerator. You could do that and then factor that. In fact, let's go ahead and figure out what that would be. So I have 63 times 28. I get 1,764. And then I would need to take out any perfect squares from 1,764. So if you would do a factor tree on this, what you would end up with, you'd find out that 1,764 is a perfect square in itself. So that's a perfect square of 42. So I would get 42 all over 63. Now that's a fraction, and I have to reduce that. So let's go ahead and divide that by 3. So if I divide 42 by 3, I get 14. And if I divide 63 by 3, I get 21. And now I can reduce that again by 7. So if I divide a 7 into 14, I get a 2. And if I divide 7 into 21, I get 3. So we finally have the right answer. Now it may have been simpler to try to simplify some of my radicals at the start. So I'm going to start that way for a second way of working it. So the square root of 28, that is 4 times 7. And the square root of 63 is 7 times 9. And what would happen is the 2 would come out on the top and the 3 would come out on the bottom, giving me 2 times the square root of 7 all over 3 times the square root of 7, which, since the 7's equal 1, I would equal 2/3. So that may have been a simpler way to do it. Moving on to the next one. Remember, the first thing we're going to do whenever we see radicals in the denominator, or we have to simplify radicals, is we're going to see if there's any perfect squares. And the second step we'd do is perhaps the denominator would divide evenly into the numerator, getting rid of any radical in the denominator. So those are two pretty easy steps. The third step, if I can't do any of those, would be to rationalize. And for example, on this one, I'd take times the square root of 36 over the square root of 36. But if I look closely, what I'm going to find is that the square root of 36 is already a perfect square. So if I would have stopped to think a second at the start, I could have had, okay, 18 and the square root of 36 is 6, so I would end up with 3. Okay, let's do the next one. Okay, so before I even start simplifying my square root, I see that I can divide 4 into 16. So this is going to be the square root of 48 all over 4 right away. So I've already made some simplification right away. Now let's go ahead and take the square root of 48 and see what we can get out of that. So the square root of 48 is 16 times 3. And the 16 is a perfect square. It comes out as a 4. So now I have 4 times the square root of 3 all over 4. The 4's cancel, leaving me with the square root of 3. Next problem, I have to multiply. So if I multiply these two together, they're both going to combine under the square root. So what I would get the square root of 60. And 60 can be factored. Now you can do a factor tree for any of these, but I just prefer to factor it because it's quicker. And 60 would be 4 times 15. And the 4 is a perfect square. It would come out as 2. So I have 2 times the square root of 15. On the next one, the two numbers in front of the square roots would multiply together. That would give me a negative 3 times a negative 4. That's going to be a positive 12. And the numbers under the square root multiply. That would be the square root of 48. Okay, we had 48 before, so I can break that up into 12. And then the square root of 48 is 16 times 3, of which 16 is a perfect square, so it's going to come out as a 4. So the 4 is going to multiply by the 12, and that is going to give me 48 times the square root of 3. Okay, moving to the next one. All the i's will subtract and the real numbers will subtract. So let's write this in a little better form. I have I, then I have subtract 6i, and then over here I will have plus a minus 5 plus 8i. So the 8i will go with the i's, and this would be a minus 5. So now I have a 1i minus 6i. That's going to be a negative 5i. Negative 5i plus 8i would be 3i minus 5. Now remember, we always write these in a form where the real number is first, so we want to put the minus 5 first. Okay, so that's the way that should look. The next one, I have a minus 1 plus 2i. Now this is a subtraction, so I have minus a negative 3, that would be plus 3. And then the subtraction also extends over to the minus 5, so it's subtract a minus 5i, that would be plus 5i. So let's combine like terms. That would be a minus 1 plus the 3, those are like terms. Then I have plus 2i plus 5i. Minus 1 plus 3, that'll be 2. 2 plus 5 is plus 7i. The next one is a multiplication, and we're going to use FOIL on that. Notice that there is no plus or minus between the two parentheses. So by FOIL, it would be 6 times this minus 5. That's a negative 30. Then the 6 would multiply by this 6i. So 6 times 6 is 36. That would be plus 36i. Then this negative 8 would multiply by this negative 5. That would be plus 40i. And lastly, the negative 8i will multiply by the 6i. So a negative 8 times 6, that would be a minus 48. And the I times I is I squared. Okay, so let's work on it some more. I have a negative 30. Now I have 36 plus 40. That's going to be 76i. Now I squared is equal to a negative 1. So if this is a negative 1 out here, that would change the sign on the 48. It would be 48 times a negative 1 would be a negative 48 minus a negative 48. So this is going to be plus 48. So combining the like terms, I have a negative 30 plus 48. That's going to be 18 plus 76i. And remember, we write the real number first plus the imaginary portion, so that would work. Okay, the next one is where I'm dividing pi, a complex number. And remember, we cannot have a complex number in the denominator, so I'm going to multiply by the conjugate of this complex number in the denominator. So that would be multiplying the top by 6 minus 6i, and the bottom by the same thing, 6 minus 6i. Okay, so now I'm going to do FOIL on the numerator. So I'll have 1 times 6 is 6. 1 times this minus 6i would be negative 6i. Subtract 6i. A negative 8 times this 6 would be minus 48i. And now I have a negative 8 times a negative 6. That would be plus 48i squared. Doing FOIL on the denominator. 6 times 6 is 36. 6 times a minus 6i, that's a negative 36i. 6 times a positive 6 would be plus 36i. And lastly, 6, this 6 times this minus 6 is a minus 36. The I times I is I squared. Okay, so let's simplify this. So I have a 6, I have a minus 6i, and a 48i. So that's going to be minus 54i. And now I have I squared here, so that's going to change this to a minus 48. On the denominator, I'll have 36 minus 36i plus 36i. So this part right here is all going to drop out. And I'll end up with 36 minus 36i squared. Okay, so I squared is a negative 1, so that's going to change this to a plus. So I've got 36 plus 36. Okay, working some more, I have 6 minus 48. So I'm going to have a negative 42 minus 54i, and the denominator will be 72. Now let's break that up into its real portion and its imaginary portion and then simplify. So the real portion is going to be a negative 42 all over 72, and the imaginary portion is going to be subtract 54i all over 72. Okay, so let's see what can go in there. Okay, for the first fraction, 6 will go into 42. And it'll go in there 7 times. So 6 into a negative 42, that's going to be a subtraction there. 6 will go in there 7 times. And 6 will also divide into 72. That would be 12 times. Now let's work on the this part, and 6 will go into 54 9 times. And 6 will go into 72 12 times. And I can see I still have a little work to do because the negative 7/12 is a simplified fraction, but 9/12 is not, so I need to take that down. Dividing 3 into 9 would be 3i, and dividing 3 into the 12 would be 4. So finally, I've got it simplified to its best state. Okay. Okay, let's continue with the next one. This is probably the most difficult one on this review sheet. What we're going to do is we need to get the I out of the denominator on this first, and then of course we'll subtract this other complex number. So let's go ahead and start working on this. I'm going to kind of divide it into 2 parts, but I'm going to write the whole problem together. So what we're going to have is we're going to need to do 5 plus I all over 6 minus 4i. And now we're going to take this and multiply by the complex conjugate of the base of the denominator. So that would be times 6 plus 4i all over 6 plus 4i. And then once I get done with that, I'm going to subtract the 2 plus 2i. Okay, so that's going to be 5 times 6 is 30. 5 times 4 is plus 20i. I times 6 is plus 6i. And then I times 4i is plus 4i squared. The bottom is going to be 36 plus 24i minus 24i. Negative 4 times a plus 4 is minus 16i squared. Once I get that, I'll subtract the 2 plus 2i. Okay, working on the this part in here, I'm going to have 30 plus 26i. And then this I squared is going to make that a minus 4, so that would be a minus 4. My denominator will be 36. The plus 24 minus 24 will go away, and this I squared will turn this minus 16 into a plus 16. Oops, I forgot to add the other part. Okay, so now what I'm going to have is I'm going to have the 30 minus 4, that's 26, plus 26i, all over 36 plus 16, that's 52, minus 2 plus 2i. Let's go ahead and split this into its real and imaginary parts. So that would be 26 all over 52 plus 26i all over 52 minus 2 plus 2i. Now 26 over 52 is just 1/2. The 26i over 52 is going to be I, that's I over 2. And then I'm going to subtract Okay, so combined, you can see that this is going to be 1/2 minus 2, so that would be 1/2 minus 2. That's going to be my real portion. My imaginary portion is going to be plus I all over 2. This subtraction would distribute to the 2i. So I'm going to end up with 1/2 minus 2. That's a negative 1 1/2. And the I over 2 minus 2i would be another minus 1 1/2. And that's my final answer. Okay, so this part here is pretty easy. I'm just saying what is I, just so you know. That's I is equal to a minus 1, the square root of a minus 1. I squared is equal to a negative 1. Okay, next part says find the value of x and y that satisfy the equation. So the real parts must be equal. So the 63 must be equal to a negative 7i. They're the real part. So let's set that up. 63 isn't equal to a negative 7x. Divide both sides by negative 7. I get a negative 9 is equal to x. For the other part, the imaginary parts must be equal. So this minus 2iy must be equal to 10i. Let's divide both sides by a negative 2i so that I can get the y alone. Okay, so those cancel. Gives me y is equal to, and the i's cancel, a negative 5. Okay, next part. Now we're solving these. So we need to get the squared piece all alone. In this case it already is, so I'm going to take the square root of both sides. As soon as I do, I need to take a plus or minus. So m is equal to plus or minus the square root of a negative 88. And let's make the negative 88. Let's go ahead and split that up into a negative 4 times 22. The negative will come out as an I. The 4 comes out as a 2. So m is equal to 2i times the square root of 22. For this one over here, let's go ahead and we need to get the x squared part. Just add the x squared all alone. It's the only squared piece in there, so let's add 10 to both sides. That gives me 5x squared is equal to 220. Let's divide both sides by 5. So now I have x squared is equal to 45. I will go into 24 times, carry a 2, 44. Now take the square root of both sides. That would give me x is equal to plus or minus the square root of 44. Let's simplify 44. And the 4, that's 4 times 11, of which the 4 will come out as a 2. Okay, move to the next one. Let's subtract 5 from both sides. That gives me 1/2 x squared is equal to a negative 10. Now we need to get the squared part alone. The 1/2 is not squared, so we need to get it to the other side. So multiply both sides by 2. That gives me x squared is equal to a negative 20. Take the square root of both sides, so I have x squared, the square root of that. It's equal to plus or minus the square root of a negative 20. Negative 20 is equal to plus or minus the square root of a negative 4 times 5. The negative will come out as an I. The 4 comes out as a 2. So I have x is equal to plus or minus, I have a 2 and an I on the outside and the square root of 5 left on the inside. And the next one, now the squared piece is the whole thing in parentheses. So I need to divide both sides by 2. That'll give me x plus 4 squared is equal to 5. Now then I take the square root of both sides. The 4 will be under the square root. So the square root of x plus 4 squared is just simply x plus 4. The other side will still be plus or minus the square root of 5. Now I'm going to subtract 4 to bring it to the other side. It goes in front of the plus or minus. So I have x is equal to a negative 4 plus or minus the square root of 5. And the last problem, which is not on your sheet, once again, the x minus 2 squared, we need to get that alone. It's the squared piece. So let's divide both sides by a negative 5. And what that's going to leave me is x minus 2 squared on this side. And on the other side, it leaves me with a negative 75. Take the square root of both sides. So if I take the square root of x minus 2 squared, that leaves me plus or minus the square root of a negative 75 on the other side. X plus 2 is equal to, now I'm going to break this negative 75 into negative 25 times 3. The negative comes out as an I. The 5 comes out of the negative 25. The 25 comes out as a 5. So I have x plus 2 is equal to plus or minus 5i times the square root of 3. Now I will subtract 2 from both sides. So I've got x is equal to plus or minus a minus 2. X is equal to, I subtract 2, so I've got a minus 2 plus or minus 5i times the square root of 3. And I think we're done.